Welcome to this lesson where we are going to discuss angles of elevation and depression. Make sure you have your math dictionary with you. You can pause the video to copy down this definition. An angle of elevation, it's an angle above a horizontal viewpoint such as sea level or eye level. You can pause the video now to copy down angle of depression. It's an angle below a horizontal viewpoint. Angles of depression and elevation are acute angles of right triangles formed by a horizontal distance and a vertical height. So in this diagram, angle 2 is our angle of depression. The flight path is considered the horizontal start, our horizontal line of sight, and the angle of depression is from the plane to the tower. Angle 1 represents an angle of elevation. The horizontal vantage point is straight horizontally from the tower and looking up at the airplane. A common mistake to make. Which of these angles do you believe is the angle of depression? Angle Q or angle A? Take a guess now. If you said angle Q, you would be correct. The horizontal line of sight of this man is this line. The angle of depression would be angle Q, where we would create this upside down right triangle to describe an angle of depression. What do you know about angle A? Well, angle A, if we were to connect this whole space, we would create a rectangle. In a rectangle, I know that this angle is 90 degrees. So let's say angle Q were 50 degrees. That means angle A would have to be 40 degrees because this has to add up to 90 degrees. So angle A is something important because we could create this triangle, but when we use our angle of depression, we like to create this upside down triangle. So we place the correct angle of depression in its proper place. Something to remember, when you draw an angle of elevation, you have a word problem and you draw a problem with an angle of elevation, you're going to draw a triangle like this. Or this corner represents my right angle, and this corner represents the angle of elevation. If we had a problem with an angle of depression, we would start up here and draw the horizontal line wherever our object may be. And we're going to create this upside down triangle where the right angle is going to be kind of floating in the air on these problems, where this represents our angle of depression. You can pause the video to make sure you have this worksheet out. I'm going to go over a couple of problems to get you started. In this sheet, it asks us to identify the angle. It asks us to describe each angle as it relates to the situation in the diagram as elevation or depression. If I look at situation number for angle 1, we have the birds, and it looks like they're looking at the ship. So from the birds horizontal, we're looking down, and so this would be an angle of depression. And we would say from the birds to the ship. For angle 2, the horizontal line of sight is the ship looking up at the birds. So we would say elevation from the ship to the birds. Angle 3, same horizontal, but now we're looking down. When I go down towards the sub, this would be an angle of depression from the ship to the submarine. And number 4, we're looking at the horizontal line of sight from the sub, looking up at the ship. So this would be elevation from the sub to the ship. Now you will do the next 4 on your own. I'm going to dive into 2 word problems from your sheet. We're going to start with number 11. It says a point on the ground is 40 feet from a flagpole. The angle of elevation from that point on the ground to the top of the pole is 35 degrees. What is the height of the flagpole to the nearest foot? So some key things I pick out are 40 feet, that's the point from the ground. The angle of elevation is 35 degrees. So we have a point on the ground and it's 40 feet away from a flagpole. It's got a nice flag on the top. The angle of elevation from that point to the top of the flagpole, so that means we're looking up. Our 35 degree angle goes in this corner. We just created a right triangle. The point on the ground to the flagpole is our 40 feet. And the question we are being asked is, what is the height of the flagpole? So that's this side of the triangle. That's our unknown. We're going to use our trig functions. Looks like we have the opposite side and the adjacent. So the opposite of the adjacent means we're going to use the tangent function. So the tangent of 35 degrees equals my opposite side, x divided by 40. And we know the number in the bottom means I'm going to multiply both sides by 40. After we multiply by 40, we know it cancels there. So x is going to equal 40. We get our calculator out, times the tangent of 35. And we get 28.00. It says to the nearest foot. So we would say 28 feet. So the flagpole is 28 feet. All right, we're going to do number 14 here. An airplane is flying at an altitude of 10,000 feet. The airport at which the airplane is scheduled to land is 50 miles away. Find the average angle of depression in which the plane must descend for landing. Round your answer to the nearest degree. Remember to convert feet to miles or miles to feet. So when we have a problem where we have 2 different units, we need to convert them to the same unit. So you can Google this, but you can say how many feet are in a mile. So for 1 mile, there are 5,280 feet. So if we wanted to convert the 10,000 feet into miles, it will help us deal with smaller numbers. If we have 10,000 feet, how many miles would that be? Well, we would take our 10,000 feet, and how many times can we divide 5,280? So 10,000 divided by 5,280, we would get 1.89 miles. If we wanted to do the other conversion, we had 50 miles And we know that 1 mile is 5,280. So if we had 50 of them, we would multiply it by 5,280. So 50 times 5,280, that would give us 264,000 feet. Now I like dealing with the smaller numbers, so I'm going to use 50 miles and 1.89 miles in my diagram. So we've got an airplane. So here's our airplane flying up in the air at an altitude of 10,000 feet. The airport at which it's scheduled to land is 50 miles away. So I'm going to draw a little landing. The plane is going to have to descend to the landing spot. Now, angle of depression. Remember, we're going to draw this upside down triangle. Whenever we see angle of depression, I like to draw the two figures, the plane up in the air, what it's looking down at, and now I draw this triangle upside down where my right angle's up here, and I can place my units. So it's flying at an altitude of 10,000 feet or 1.8 miles. So that's the vertical side of the triangle. And the average angle of depression for which the plane must descend for landing, well, it's scheduled, it's 50 miles away. So from here to our landing spot is 50 miles. And we are wondering what the angle of depression would be. Now we have our right triangle, so it looks like we have the opposite side and the hypotenuse. So that means we're going to use the sine function. So the sine of our angle is equal to the opposite divided by the hypotenuse. And to solve this, we need to use the inverse sine function. So we grab our calculator, we make sure that it's in degree mode, otherwise we're going to get a weird answer. So make sure it's in degree mode, and now we can use the sine inverse of 1.89 divided by 50. And I get 2.16 degrees. And it said to round it to the nearest degree, so we would say 2 degrees. So that's a really low angle to be able to land that plane.